We're talking about shoes, we're talking about warehousing. We can all relate to shoes, right? We all wear shoes. We all have these 1 or 2 pairs that we find both comfortable and stylish that we can wear in our day-to-day lives. And you know how much diversity, so many styles, so many colors, so many SKUs. If you want to buy shoes online now, you can filter by color, plus size, and then availability, all that good stuff, and it's crazy, right? So to be able to actually get that kind of product diversity and actually get orders on time at home or in store, we need a system like this one. So this is what this is about. So here's our agenda. So first of all, we're going to introduce Brown Shoes and SimWell, and we're going to talk about this project at a high level, business context, objectives, scenarios. Then we're going to do a model demonstration and a technical overview of the modeling and conclusion. So this is SimWell. We are a global consulting firm. Our main focus is simulation. We've been doing simulation for several years, and we also work in optimization and digital twins. So we develop all kinds of solutions for all industries, basically. And we started up in 2015. We are close to 70 people worldwide as we speak. And we are here as AnyLogic partners. Obviously, this is an important event for us. It's exciting. And so we've been partners since 2018. We are actually the partner who delivered the North American trainings. So if you register for the training online, you're going to get a couple of SimWellers to take care of you, and that's what we do. So this is us in a nutshell. So, and this gives you an idea of where we are. So there's a good cluster in around Montreal and around Eastern North America. We have a team in India and in Australia as well now. This is Alexandre Hubert. So he's the guy, our main contact at Brown Shoes. He's actually an industrial engineer and a friend. So he's VP of Technology and Logistics. He couldn't be here for personal reasons, unfortunately, but we'll try and make him proud. So yeah, he's been our contact for a few years at Brown Shoes. We worked with him a few times. And so basically, Brown Shoes, in a nutshell, 70 stores across Canada. They are the North America's leading independent footwear chain, 83-year-old family business, and they take pride in logistics excellence, state-of-the-art automation. So this is what this presentation is about, state-of-the-art automation in their warehouse, and so best-in-class shopping, world-class customer service, innovative store design, quality. This is Brown Shoes in a nutshell. In Canada, everybody knows Brown Shoes. Okay, they got those nice bags, and everybody notices them, so that's it. So here's a video. So since Alex couldn't be here with us for this event, we have a little bit of an introduction video where he talks a bit about Brown Shoes.
At Browns, I'm the supply chain director. I take care of transportation, distribution center activities, as well as all of the e-commerce. Browns is a family-owned business. Last year, we just celebrated our 75th anniversary. We operate under the B2 and Browns banners. Overall, we have just over 1,200 employees. I think that every Browns employee is very proud to work for a company that delayed 10% of its pre-tax profit year after year. In 2014, we were at the point where we had 3 warehouses. All 3 of them were at full capacity. So as a company, we decided to invest in a new facility. One of the things we looked at was a state-of-the-art automation system.
All right. Thank you, Alex, for when you watch this later. So that was it. Basically, oops. We go back. All right, so a little bit of context about the project. So Brown Shoes, like he said, new facility in 2015, a nice distribution center and headquarters, and they have implemented their first ASRS, so automated storage and retrieval system, which is basically an automated warehouse for storing all the products. And you'll see the word OSR pop up in different places in this presentation. The OSR is basically the same thing as an ASRS. It's just a branding thing from their equipment provider. So picking stations, so that's what we are focusing on here, so goods to person. So basically the products, all the shoes are stored in big cartons in the ASRS system, and then depending on whether they're fulfilling a web order or a stores order for a certain number of different specific SKUs that they need, this system will call the proper cartons that come all the way to the picking stations. They move up, and then they just scan the right box, put it in the other box, and it goes out for the actual order to the destination. And that's, in a nutshell, what this is about. Now, so what happened between Brown Shoes and SimWell, we started in 2018, actually. We built the first model for them. It was another DS simulation software, actually, at the time. It was focused on just the picking stations themselves, and it was already an interesting project at the time. We actually used it as well for simulation competition in the past, as it was a nice case. And then 2023, something happened in the spring. Alex Hubert calls us back, and he says he wants to test a few options for expanding their existing system. So it's been the same since 2015, and they've been operating with a certain number of picking stations, the same configuration for the ASRS, and so on. And they're looking at a few different things, which we'll review a little bit later. And then obviously, at this time, I felt like instead of maintaining an older model, I wanted to actually transition into AnyLogic, because we use AnyLogic for a lot of our projects. We love it, obviously, and it enables us to add accurate 3D movement and animation to this model, and also scalable model components, more reusable and more adjustable pieces in the actual model. And then we can also use the cloud/model manager for experimentation and sharing the model with the client, which he has enjoyed a lot until now. So we'll go with an overview of the system. Okay, so this is a video of our model here. What you see for now is just the picking stations themselves. So you see the cartons coming in. They have the number of the picking station they're going to be going to. And then we are not modeling the actual outbound orders. Okay, so we're focusing on just the picking activities here. So you can see when the pickers are busy, they're getting blue, they're turning blue. So we have the delays, the proper task times and everything here. And then you can see the conveyor that actually brings the cartons from the ASRS system. So now we're showing the ASRS system, which is the three main lanes. And they have the lifts and shuttles, which basically retrieve the cartons from the different cells and bring back the cartons at the end and store them again. Then we turn down the other layer, which is the empty carton system and the decant station. So on the far right, you see that box, that little thing. And I can't point, but I think you see what I'm talking about. So this is a possible expansion option. So they want to look at the carton erector, which is a machine that just folds the carton and just saves time for the pickers to actually not have to always build the boxes for the orders they're picking. And then we moved around and look at the OSR or the ASRS system in a little more detail, so you can see the activity in here from that angle, the lifts and the shuttles moving around the boxes and storing them on the buffers on the side there. Okay. So this is basically the current system and one of the options. This is what we've been modeling. And so now the purpose of this year's project was to consider a few options that they may want to invest into. So extra picking stations and potentially a second loop, which would be at a different level to have more material handling capacity, because this loop gets really congested sometimes. They are considering a new decant station, so when they bring in new product, when they want to load up a whole bunch of new pairs of shoes in the system, decant is another area, and you could see it in the previous, in the video just before, if you noticed, there was a slope conveyor, basically bringing the new products into the ASRS system, but from the bottom, below the picking area. They might want to do another ASRS lane, so they kept space. They had 3 lanes right now, and they kept actual physical space in the warehouse where they could actually implement a 4th lane that would add capacity. And so the carton erector, which I mentioned just before, and we did all kinds of sensitivity analysis on the different resources, like the ASRS lifts. They actually have failures, obviously. They can have all kinds of things happening. So scanning errors, lift errors, and yeah, and also the model will allow training the warehouse operators and the managers and see the impact on productivity of the different components. So this is the overall scenarios and situations we want to use. So this second video here actually shows the same system. So you can see actually here we have 2 extra picking stations, and you can see the second loop that was added on top of the first one here. So we're going to move between the views here, but because it gets busy, and that's why we created the toggles to be able to focus on different areas of the system here, be able to really view only what matters depending on what we're focusing on at any point in time. So here you see that second level that would allow them to have to fetch and put away more cartons and to have extra picking stations. So in this case, they would connect like 3 new stations. 1 station would move to the second loop, and the 2 new stations would go to the second loop and to balance things out. So that's a possibility. So we've executed quite a few scenarios. We're actually not done yet. We're going to be keeping analyzing a lot of the possible options in the next few weeks and months with the client. But we can, I mean, here there's just a sample results with no actual numbers here, but you can see a plot of, I think it was 20 replications, so 20 runs of the base case versus the full-blown scenario with the 2 loops, the 6 stations, and the extra capacity that we gain on picking by having the carton erector and the automated conveyors for empty carton handling. And on the side, we can see a detailed plot, just a scatter plot of a sensitivity analysis based on lift failures. So if we have more time between failures, less failures, see how much it impacts the actual throughput of picks over a few hours period. So another pretty nice feature here that we want to illustrate is that we've been using the model to, mostly we wanted to make sure that the conveyor was really realistic and validate the behavior. So on the bottom left, we see the user here clicking that little edit box, and then they're basically selecting a cell and blocking it. So in real life, it happens. A carton can just pivot a little bit, something happens, and then it just blocks one of the cells. And then we can see the ripple effect, and we can see the boxes accumulating, and then at some point the user, as in real life, goes and removes the box that's holding up everything, and then we can see well, actually I'm speeding up the view there, you'll see it in a few seconds, and then we can check how the system actually reacts and see if the recovery time after this incident is realistic there. Okay. I guess I can skip it. Okay, so here, okay, there you go. So, am I already here? Yeah, okay, sorry. So, okay, so if we're now at the stage where I want to discuss a couple of the key technical challenges that we were facing, I guess, while building this model. So there's one thing in particular is that this conveyor type is not, this exact type is not a built-in feature of AnyLogic. So it's roller conveyors, but they have a sensor at each physical space where the carton can sit, over all the entire length of that loop. And so these cells, basically, there's a sensor, right? There's a visual sensor, and any time a carton moves, then it releases the previous cell. Once it completely releases the previous cell, then the other carton that follows can actually enter that cell. Okay. So that's how it gets controlled, and that's why. So that's it. So basically, to model this, and I want to just start the video again, but it goes full screen, and then you lose the rest of the slide. Doesn't matter. So you can just focus on what you're seeing here, which is what I just described. So every carton just has to stay. There's a different delay when you're moving sideways and turning 90 degrees there, translating in a corner, and so on. And so yeah, to be able to model this, you can see the agent structure here, the hierarchy of the objects that we've designed. So we basically created a resource for the actual capacity that you want to limit. So each cell has a capacity of 1 carton, and that's it. And then basically there's that cell, which is a nice colorful rectangle that we can that actually allows to draw the entire loop and the incoming inbound and outbound branches. So all of that becomes one conveyor loop AnyLogic agent object, and then that's it, and then it works. So, so that's the idea here. Another interesting challenge, obviously, was the ASRS/OSR system. So this is, it's a 3D structure, obviously, and the objects are the lanes. So you saw 3 lanes there, and each of the lanes has 2 lifts. And then there's the shuttles. So every level has a shuttle that goes just horizontally and just goes and either retrieves or puts away a carton. And then they move them all the way to nearby the lifts, but then they have to wait because you can't just always transfer directly to the lift. So they have the buffer spaces. So every single level has a buffer space on each side. And I could go back to the video, I guess, but anyway. So that's the structure, right? So we built the shuttle themselves, and they're custom-built AnyLogic agents with a certain look and feel and behavior. And then we have the shuttle inside each of the level agents, and then a bunch of the population of level agents live inside the lane, and then the lane population lives inside our master agent of the model. Hope that's clear. So next, model manager. So a quick print screen to highlight the benefits that the client and ourselves have gotten from actually sharing the model using the AnyLogic cloud here. And so for demonstrating the model at first, as we develop it, we could share a version with the client. He could just look at it on his own time, give us feedback. That was very helpful. And then testing and then validating results and getting some outputs of different scenarios and analyzing the results directly or downloading results if we want. So it's been a great, awesome asset to bring into this project. So much appreciated. And next. So next steps. So this project is far from over. Basically the modeling is done. We don't really need any new features, but at this point there's a lot we still want to test. The client has, just in terms of timing, it just happens that we didn't finish testing everything, and he's going back and forth with his equipment provider. He actually uses the model to show to his automation system provider, we've been modeling this, it looks like that, can we do this, is this possible, how much did that cost, and so on. So this is really helpful for the client to be able to demonstrate using the model and discuss with his colleagues as well what we want to do here. So one example is earlier I said there's the 2 loops, and then you got the 4 original stations. They may want to migrate one station to the second loop, and then after we did this presentation, he talked to the equipment provider, and apparently it's not that much of an option. So it would probably, the original 4 stations would probably stay on the first loop, and then he would have to put two more. The only new ones would end up on the second loop. So it's a living project, and that's where we stand at this point. So there's a few things that might happen. So next step, one of the most plausible options is that probably they're going to implement the empty carton feeding system with the erector, and basically at this point, the model allows us to test different configurations, exact routing of the conveyors, so that it has to work with all the other conveyors in place. Because the real system, like I said, has other conveyors for the outbound orders. When they're ready, they move out, so there's even more layers than that. You saw that it was already pretty cluttered, right, when we want to look at it and we want to turn off certain pieces. So in real life, there's a lot of conveyors. And so the model allows us to basically design that new empty conveyor system and see where they would put sensors so that they trigger new empty boxes could either go for orders or for the decant. And they may want to they basically want a certain stock of readily available boxes on either side. So they need sensors, and they want to make sure the carton erector triggers itself to run at the right moments. So other than that, we've been testing all kinds of operational parameters. There's the thing they call fetch and prefetch. So basically when you call a certain number of specific cartons from the ASRS system, they go all the way to the buffers, but then they don't always take them from the buffers and send them to the station right away. They have these 2 levels of control, prefetch and then fetch to the station. So they have these 2 counts of number of cartons you want circulating so that you have enough for the pickers to be busy, and at the same time, you're not clogging the whole system too much and locking down the loop, which could happen. All right, so at this point, we need to run more scenarios. We're going to be testing combinations of these different features we've been implementing and making sure that they make the best decisions possible. So they're evaluating the different CapEx scenarios, estimating implementation cost, calculating potential benefits, increased throughputs, decreased operational costs, and like I said, the empty carton system is likely to happen. And what's good news now is we have this highly maintainable model. We'll keep it over time. SimWell and Brown Shoes we hope we'll keep collaborating for years to come and keep maintaining this model. And it can be used for different purposes, future project and training, and just demonstrating potential operational tactics and so on. So we're getting close to having it. At this point, we can basically say we have a digital twin of this important area of the distribution center for Brown Shoes. So that's it. Thank you. Any questions?
Great presentation.
Thank you.
AnyLogic, couple of questions on this, basically. How much of an impact the inbound operations on the ASRS? I mean, you're only showing the outbound side of it, right? But
right.
It has to feed in inbound data,
right.
inbound stuff.
So there's the decant, and that's not something that is as consistent in terms of number of moments where they do decant is not like, because picking is like the day shift, they just pick all day, basically, right? And decant has to happen at certain moments where they get truckloads of new product and so on. We haven't looked into a lot of detail as like exactly a lot of historical information or anything about when it happens, but what we did is we basically run a worst case, right? We have the decant time interval or frequency of the decant station. We can just run the model and pretend, okay, can we do a day shift where there's a lot of decant happening at close to like the peak rates that they're expecting? And that's basically what we do. Then maybe that's too much detail, but like for now the decant goes to the bottom, and then they could probably use the second loop if they implement the second loop to connect the decant up there instead, and it just creates traffic only on the second loop. So there's a couple things they can try to do.
Okay. Second question is, are there any other alternatives? ASRS is a huge system and then a lot of capital investment. Did they consider Kiva-like, person to, goods to person kind of a system, where in which I believe it is most of it is carton pick. Is it each pick, carton pick, or a combination of, I'm talking about a case pick, each pick kind of thing, or is it a?
Yeah, in their case, it's all the same. Like you're either picking a web order and it's just one or two pairs, or they're picking multiple cartons worth of shoes that are going to a store order for replenishing a store. And we haven't discussed like other completely different operational tactics because we started modeling this and they had just already acquired the facility and all the equipment. So we just assume we go with it and we just keep improving what they already have.
Will you be able to simulate if it was goods to person, kind of a robotic, single robot bringing a case, basically, right? A shelf full of shoes to a picker?
Yeah, well we haven't even discussed anything like that, but it's definitely something we could model. You mean like a completely different type of storage, and it would be robots going in and picking?
Yeah, Kiva robot. Amazon has the.
So not for this project, but we could do it. Obviously.
And then, is there any cost-benefit analysis? Hey, you are adding 2 pickers here, right? How does it impact your cost versus the congestion that is, how much of an impact congestion? Also, considering your decant operations, you need to consider that as a serious issue. Because you get these containers from China, right? What is it called?
Yeah.
A container, and then you need to decant those.
Yeah, for sure. These questions would be good for Alex if he was here, but because I don't know everything about what Brown Shoes does, obviously, but I don't do the financial analysis. He's going to take care of that, and he's going to compare operational benefits compared to capex over the next X years, right?
Yeah, thank you. And then anything else happening besides AnyLogic? Are you writing some proprietary Java code or something?
Oh.
I'm asking how much of it is AnyLogic versus your
Oh,
own?
for this model in particular, that's AnyLogic.
Okay.
It's just, I mean, of course, there's Java code in the model. That's why it's good. Okay, that's how you build good AnyLogic models. That's my opinion, and that's what makes AnyLogic really good is that you can write code.
Yeah. Okay.
And that's why it's powerful. So yeah, of course, there's a bit of Java in a lot of different places that makes it a coherent piece, right? But there's full charts, there's state charts, there's Java.
Okay, great presentation once again.
Thanks.
I want to ask a question about the inputs to this model. Were you considering the different demand flow of orders for this new warehouse and how demand was going to flow differently from the other warehouses?
Yeah, so they only have one DC, right? This one DC for the 70 stores in Canada, and there's no huge data analysis in this one. We're basically going at max speed, right? The key is just the throughput, and we're just modeling a typical busy week, day shift of picking, right? So yeah, we put in some variability on the time, like all the delays for especially for the picking, because the rest is automated. There's not a lot of variability on the ASRS side, but yeah, for picking and then the lift potential failures and the scanning errors, which were turned off for the videos, but once in a while you get a box that just doesn't scan and just gets a free turn on the loop, this kind of thing. Other question?
Another question. It's very cool that your client is using the model with the warehouse equipment provider to kind of show what they're envisioning and ask questions about that. I guess that means you didn't have any collaboration with that equipment provider in putting together the model. Is that true?
I did not. So did everybody get the question? So equipment provider, they're collaborating with Brown Shoes, and they can now actually demonstrate what they could potentially do together by looking at this model, obviously. So no, we didn't have any direct interaction. Our client is super smart and easy to work with, and he gets us the information. So he didn't. But we could have he could have decided to sit us down with them and do some actual work sessions and so on. But
yeah, I'm curious
not
if you
the
see possibility for that in the future, to design with them,
Sure.
or
Yeah,
I'm guessing
could,
this isn't a
definitely.
capability they have.
Thanks, John. Thanks.